y now ties with x and with z. Therefore, it's no longer an intermediate Condorcet winner. So this independence property is violated. And just as a remark aside, strong Condorcet winner consistency satisfies all of them. But the whole point of the exercise is to go beyond it. So. And again, examining these properties is a way of asking, what do you have to pay for this? In what sense, what do we lose if we have this generalization? And one loss is this loss of independence. Now we have another proposal, and that's a refinement of intermediate Condorcet winners by focusing attention on intermediate winners that are maximal, in the sense that among all intermediate Condorcet winners, the instances of a strict inequality is maximized. That's precisely what's happening here, right? There's a defined distinction between x and y, because x beats two alternatives, z and w, y only beats one. And that would be one way of discriminating between the two of them, selecting from the intermediate Condorcet winners only those that are maximal. That is, to display the maximal number of wins. How are we doing with time?
25 minutes.
25 minutes. Good. So maximal intermediate Condorcet winners are defined as follows, as I just said. So if x is an intermediate Condorcet winner, is a maximal if, well, the number of inequalities in defining the status of an intermediate Condorcet winner is maximal. It is, if you look at the number of candidates Z in S, such that the majority score of X against Z is greater than the majority score of Z against X, is greater than or equal to the same expression. I don't write it out again. X is replaced with Y for all Y in the set of intermediate Condorcet winners. For R and X, right? So that's what we mean by maximality, right? Now, existence is exactly the same as existence of intermediate Condorcet winner. If intermediate Condorcet winners exist, maximal intermediate Condorcet winners exist, because everything's finite, right? Can calculate these numbers. The ones with the highest number are selected. And of course, if the maximal ones exist, then some of them exist. So I use the short abbreviation maximal intermediate Condorcet winner, R in S, to indicate this set. And then, of course, we can define maximal intermediate winner consistency, Condorcet winner consistency. We're not going to define maximal intermediate Condorcet loser consistency. Why? Because we think all the intermediate Condorcet losers are unpalatable. So we want to toss out all of them, not only the ones that are minimal in that sense, right? So there's a slight asymmetry, but I think a well-founded asymmetry. But the question now is, does this help us in terms of the properties that this function has? And it says, well, not really, because we're just going to give up one property for another. So if we look at the properties of maximal intermediate Condorcet winners, we retain exclusion of dominated candidates, because for the same reason as intermediate Condorcet winners themselves, they cannot possibly select candidates that are dominated. Now they also satisfy independence of unanimously worst candidates. but pairwise justifiability is no longer satisfied. And here is an example. Let's see, again, we have 4 candidates, 2 voters, and we consider the feasible set of candidates that consists of the universal set. Now consider the following profile. For voter 1, we have x is better than z, better than y, better than w. For voter 2, we have y better than w, better than x, better than z. In this case, the set of intermediate Condorcet winners, and in fact maximal intermediate Condorcet winners, is given by x and z, x and y, x and y are in a tie, x beats z, y beats w, x is in a tie with w, and y is in a tie with z. For both of them, we have 1 win. 2 ties, 1 win. So they're both maximal. Now, modify this profile by interchanging the rules of z and y in the first order. So we get x, y, z, w, y, w, x, z. What happens now? X beats z, x draws with w, x draws with y. X is still an intermediate Condorcet winner. Y draws with x, but now y beats z and y beats w. So y has 2 wins and one draw. X has only 1 win. So x no longer is a maximal intermediate Condorcet winner. Although nothing has happened to the relative status of x, right? All that happened here is that y got promoted and x stayed where it was. And in a way, for me, the explanation behind this violation of pairwise justifiability is that if you have as a criterion the notion of a maximal intermediate Condorcet winner, you can't do this all by yourself, right? If you want to be a maximal intermediate Condorcet winner, you not only have to beat or tie with all the other candidates, but you have to satisfy an additional property in comparison to your companion intermediate Condorcet winners. And this lack of reliance on your own juices, so to speak, is what messes up pairwise justifiability. Now, you can ask yourselves, do you prefer independence or pairwise justifiability? I'd say, well, it depends on the day you ask me. But I think most days I would tend to favor pairwise justifiability because I find it more closely aligned with the underlying notion of Condorcet's objectives. But that's not a very firm, reasoning. In a way, the bottom line is that I think both of them have their attractions, and neither of them satisfies everything. But that's again not too surprising because, as we all know, in social choice, not much comes for free. Right? If you want to generalize something, gotta pay somewhere. Time?
20 minutes.
20. Good. So then maybe I should probably say a little bit about earlier proposals. Fishburne has analyzed Condorcet winners from all angles you can imagine, and he came up with a few different notions. Most of them are actually problematic because they involve the choice of weak Condorcet winners, which I already alluded to is not a feature that is very attractive to us. One proposal that's probably the most serious one, I think, is the notion of a Smith set. Smith proposed to generalize Condorcet by saying, well, instead of focusing on a single candidate that beats everyone else in a pairwise comparison, let's allow for sets of alternatives that beat everything in the complement. They don't have to beat each other, but they have to beat everything in the complement. Now, this is it's an interesting proposal, but it has a very fatal flaw, and that is it doesn't satisfy the exclusion of nominated candidates. So you can be